Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone. Welcome to session 3, learning by solving problems on carbohydrates and nucleic acids. Recall from lecture 15 and 16, Organic Chemistry 3. A nucleoside is made of nitrogenous base, usually either purine or pyrimidine heterocycles, and 5-carbon carbohydrate ribose. Here we have base, pyrimidine heterocycle, and we have here ribose. We call that nucleoside. Nucleotide is simply a nucleoside with additional phosphate group or groups. Here we have monophosphate, just only one group, could be di or tri. So here we have again base, we have carbohydrate, we have the phosphate. We call this nucleotide. Dinucleotide is a nucleotide consisting of 2 units, each composed of phosphate, pentose, and nitrogen base. Here we have dinucleotide, we have base, sugar, and phosphate. Heterocyclic base, sugar, and phosphate. If we have units, nucleotide units, 5 to 50, we call that oligonucleotide. For each of the following structure, identify base, carbohydrate, nucleoside or nucleotide, its DNA or RNA system. Let's take the first one. Well, we have base and we have sugar, no phosphate, so this is nucleoside. It has a pyrimidine base, thymine. It has deoxy carbohydrate because there is no OH on this carbon. Since we have deoxyribose, so therefore it belongs to DNA series. This compound, again, we have, here is a base, here is ribose, sugar, so it belongs to nucleoside again. There is no phosphate. So, since we have here OH and here we have an OH, so it is ribose, therefore it is ribonucleic acid series, RNA series. For this compound, we have again pyrimidine base, we have ribose, and we have the phosphate. So it should belong to nucleotide. We have the phosphate ester, we have pyrimidine base uracil, we have ribose. So since we have in here an OH and OH in here, so it's belong to ribonucleic acids. So it's RNA series. Which of the following structure is a nucleoside? Nucleoside structure has base plus sugar. Here in the first structure, we don't have sugar, so this is not a nucleoside. In structure B, we don't have base in here, no base, so it is not a nucleoside. For this structure, there is no base in here, that is not a base. heterocyclic containing nitrogen, right? So no base, no nucleoside. In here, we have the base, we have the sugar. Yeah, this one is a nucleoside. Which one of the following structures is a naturally occurring nucleotide? Nucleotide means base, sugar, plus phosphate. In the first one, A, we don't have sugar, we don't have phosphate, so it's not nucleotide. In B structure, we have base, we have sugar, but we don't have phosphate. We have sulfonate, so that's not naturally occurring nucleotide. Here we have base, we have ribose, we have phosphate. This is naturally occurring nucleotide. Here we have a base, but it's not connecting through N carbon bond, and there is no phosphate. No phosphate, which means that this is not a nucleotide. Well, we have a base in here, we have carbohydrate in here, ribose, we have phosphate, but it is not connected. Carbon nitrogen, this is not the proper nitrogen. The proper nitrogen should be this one. Okay, so this is not naturally occurring nucleotide. What are the reagents 1 and 3 used in nucleic acid synthesis? This protected nucleoside. What happened here is deprotection and removal of dimethoxy trityl group, and we can do that using trichloroacetic acid. Now we have to couple this OH to this phosphorus in here. We catalyze that using tetrazole. Now we have to transfer the phosphate triester phosphorus 3 to phosphorus 5, oxidize it. We can oxidize this phosphorus using iodine water pyridine mixture. See you next session.